And good morning, everybody. Here is a concept map for Calculus AB Free Response 2008, and this will be question number 5. And as always, the disclaimer is these are just kind of concept maps or walkthroughs of how to approach the problem. They're not the final answers or the final solutions or all the support work that you would want on the actual AP exam, but it is a walkthrough of how to get the problems started. And let's go ahead and look at question number 5. So question 5, it says consider the differential equation. So they're giving you a first derivative of something, dy dx, and this is the equation where x cannot be 0, so you can't have 0 in the denominator because you can't divide by 0. This is a slope field question. So part A, it says on the axes provided, sketch a slope field for the given differential equation. So the big idea here is, remember, the job of the first derivative is to calculate the rate of change or the slope on something. So for part A, what you're going to want to do is just pick all the different ordered pairs in the slope field. So you're going to need to do all these different points, and whatever the ordered pair is, x comma y, for that particular point on the graph, you're going to put that into the first derivative, and that will compute the slope there. So if we just went ahead and chose a point, let's say we wanted to work with this ordered pair, so we're at -1 comma 2. So for this one, we're going to go ahead and we're going to compute dy dx such that we're at ordered pair -1 comma 2. So the x value will be -1. So we're going to use this equation to compute this. So the x value is going to be -1. So that's -1 squared. And the y value is 2. So that's going to be 2 minus 1 up top. And that's going to get you 1 over 1, which is 1. So right at that point, we're going to have a slope of 1. So to answer that, you're going to want to do your best to kind of represent a slope of +1. So it should be definitely a positive slope, and it should be about a 45-degree angle to kind of represent a slope of 1 traveling through that point. And then you'd want to do that for all the other points on the graph. And for part B, so part B, it says find the particular solution. So the particular solution means they're going to give you an ordered pair so you can solve for C. So remember, this is an ordered pair, so it's saying when your input is 2, your output is 0. So they're giving you a particular ordered pair 2 comma 0. So input output x comma y. And they want you to solve the differential equation. To solve a differential equation, that means bring it back to the original equation y. So you're going to need to separate your variables on this one. So let's go ahead and transfer this equation over to a slightly bigger screen. So we have dy over dx is equal to, and the equation was y minus 1 over x squared. So separate the variables basically means get all the y values on one side and all the x values on the other side. So the first thing I would do is cross multiply. So y minus 1 multiplied by dx equals x squared multiplied by dy. And you're going to have to divide both sides by x squared to get the x squared over with the dx, and divide both sides by y minus 1 to get it over with the dy. So you're going to end up with 1 over y minus 1 dy is equal to 1 over x squared dx. And from here, you can go ahead and start thinking about anti-deriving. So if we now take the antiderivative of both sides to do this one, You're going to need to probably use U substitution, where this is going to be your U statement. You're going to get 1 over U, and that's going to kind of lead you down the road of natural logs. To do this one, on the other side, you're probably going to want to change that 1 over x squared to a x to the negative 2, and then you can just reverse your power rule and go up a power and divide by that power. So to finish this, you're going to want to anti-derive both sides. Don't forget your plus c when you're all done with what you have. So you're going to end up with some sort of equation, your plus c, and then that's where that ordered pair is going to come in. They gave you that ordered pair at the beginning. They said it was 2, 0. So you're going to use that ordered pair, that condition 2, 0 to actually solve for the particular solution C. And that should get you started on part B. And part C, it says for the particular solution that you just created in part B, they want you to find the limit of that function as x goes to infinity. So you're basically looking for what is the function approaching as the x value gets really, really large. So we talked about that when we studied horizontal asymptotes. For this one, you can probably just plug the fact that x is going to infinity into the equation that you generated from part B. So once you get your equation, put x going to infinity. So wherever you see an x in the equation, you can go ahead and put a positive infinity. And probably the big idea you're going to need for this one is realizing that if you end up with 1 over infinity, that's just a really, really, really small fraction. So that's basically approaching 0. And then you can work the problem from there. And that is a quick walkthrough of this particular free response question, year 2008, number 5. Remember, those are not the final solutions. That's not what would be given a whole lot of credit on the AP exam, but that should get you started and going in the right direction, and then you can finish up all the details to finish that problem.